There was a lot of speculations on social media, but I figure that either it's one of the moons, most likely one of the moons of Mars, or perhaps a very long exposure of 3i Atlas.
All right, so picture this. October 3rd, 2025. Every single telescope near Earth, from the biggest observatories to backyard setups, was scrambling to track the third interstellar comet humanity has ever laid eyes on. It's a huge deal, right? But here's the kicker. The real money shot, the jaw-dropping reveal, it didn't come from Earth. Nope, it came from somewhere else entirely. Mars. In one absolutely frantic, nail-biting 48-hour window, the European Space Agency, or ESA, pulled off a feat of cosmic acrobatics. They swiveled two of their Mars orbiters, spacecraft that were built, optimized, and dedicated to studying the red planet, away from their primary mission. They pointed them at a patch of darkness that, to the untrained eye, looked like absolutely nothing. And from that patch of nothing, they snagged the clearest, most astonishing images we have of a comet born around another star. This isn't just cool, it's groundbreaking. This is the first time ever that we've seen an interstellar visitor, not just from orbit, but also from the surface of another world. And let me tell you, the data coming back are already ripping up the old trajectory books and rewriting them from scratch.
This video is sponsored by Upstream. Want to grow your YouTube channel faster? With Upstream, you can run a 24/7 live stream using your pre-recorded videos. Since live streams rank higher in search, you'll gain more views, more subscribers, and more revenue. And it's not just YouTube. Upstream lets you multi-stream to up to 10 platforms, design custom layouts that match your brand, and schedule your content so your channel is live even when you're not. Sign up free today with the link in the description, and if you decide to upgrade, you'll get 20% off your first month. Start streaming smarter with Upstream.
Why is this such a monumental achievement? Well, interstellar objects are basically cosmic time capsules. They're these incredible wanderers that cross the vast, unimaginable gulfs between stars, bringing us samples of alien planetary systems. Before this, we'd only ever officially confirmed two of them, 1I Oumuamua back in 2017, and then 2I Borisov in 2019. Both were spotted from Earth, both were incredibly tiny, and honestly, both were gone so fast that we barely had time to wring out any real details before they vanished back into the black. Now we have 3I Atlas, first spotted in September 2025, making it number 3. And every single one of these new interstellar visitors is like getting a free sample of an alien planetary system. They're literally bits of other star systems zooming through our own. But here's the challenge. They move so incredibly fast, the entire observing campaign for these objects often has to fit into a matter of weeks, sometimes even just days. It's a blink and you miss it kind of situation. So getting spacecraft already at Mars involved in this chase, that buys us three absolutely massive advantages: sheer distance, the power of parallax, and the incredible ingenuity of using instruments that were never, ever supposed to do this kind of job. This whole thing truly was a cosmic coincidence, a stroke of astronomical luck. The comet's path almost impossibly grazed the ecliptic, that's the plane of our solar system, at an incredibly shallow angle. This meant that it dropped to just 18.6 million miles, or about 30 million kilometers, above the Martian surface on October 3rd. Now, to put that in perspective, that's about 6 times the distance between Earth and our moon. But in astronomical terms, that's what we call whisker close. It's practically skimming by. More importantly, this incredibly close approach meant that the very same object could be seen from both Earth and Mars. Think about that for a second. That gave us an astronomical baseline of around 240 million kilometers. And that, my friends, is absolutely perfect for triangulation. If you want to pin down an object's precise location and trajectory in 3 dimensions, having 2 widely separated points of observation is gold. ESA mission planners, sharp as they are, realized this opportunity back in late August, and that's when the frantic rewriting of observation sequences began for 2 of their workhorse orbiters, the ExoMars Trace Gas Orbiter, or TGO, and the venerable 21-year-old Mars Express. Meanwhile, NASA's Jet Propulsion Laboratory, ever the silent achievers, quietly started stacking long-exposure sky scans from Perseverance's navigation cameras at the exact same time. Nobody was shouting about it from the rooftops, they just did it. Because when you have a window like this, you know that if you miss it, the comet is just gone forever. Now, let's talk about the sheer technical gymnastics involved here. These cameras, whether on TGO or Mars Express, were optimized for one thing: a bright, ruddy planet filling their entire frame. They were designed to look down at Mars, not out at a faint, fuzzy dot scooting across star fields. We're talking about a 20th magnitude fuzzball here, thousands of times fainter than their usual targets. So first hurdle, how do you stop an orbiter from tracking Mars, the very planet it's designed to orbit and study? Engineers had to switch off the planet relative guidance systems entirely. They then locked the spacecraft to inertial space, a maneuver that, for TGO, had never been attempted for more than a mere 90 minutes. This time, they needed it for much longer. Second hurdle, exposure time. CESIS, the incredibly sensitive color imager on TGO, normally tops out at 12-second integrations before electronic noise completely swamps the picture. But to catch something this faint, they needed more light. So the team took 150 of those short frames and then painstakingly stacked them together, all while compensating for the comet's surprisingly fast 34 arc-seconds per minute motion across the sky. That's like trying to take a crystal-clear photo of a tiny, distant firefly while you're both on a roller coaster. Third, and perhaps surprisingly, was data. Mars Express, bless its heart, is running on a 1990s-era 6-gigabit solid-state recorder. That's not a lot of space when you're talking about hundreds of high-resolution images. So everything, I mean everything, had to be compressed, queued up, and then downlinked during those incredibly brief windows when the spacecraft could actually point its antenna back towards Earth. It's a testament to the engineers that by sunrise at ESA and Darmstadt, the pictures were on the ground. And they weren't just pictures, they were crisp, beautifully resolved, and unmistakably showing a distinct coma and a short sunward spike of dust. Now, this image, which quickly became NASA's image of the week, created quite a buzz. It looked long and symmetrical, almost engineered. But was it really? See, the rover's camera is designed to see tiny details nearby. When it looks at something far away, like 3I Atlas, which was nearly 38 million miles from Mars during its flyby, each pixel suddenly covers a huge chunk of space, about 12,000 kilometers across. In that photo, the bright stripe looked about 4 times longer than it was wide. If you do the math, that makes it seem almost 50,000 kilometers long. That's way, way bigger than the object could possibly be. Earlier measurements by the SphereX mission had placed an upper limit on the object's true size at just 46 kilometers, assuming it reflects about 4% of the sunlight that hits it. The NavCam stripe, then, was about 1,000 times longer than the real object could possibly be. If 3I Atlas really were a 50,000 kilometer long cylinder, it would have appeared enormous in the Hubble Space Telescope's July 2025 images, around 23 arc-seconds across. But in reality, Hubble saw nothing of the sort. It appeared as a tiny, unresolved point of light.
That means the stripe couldn't be a physical structure. It had to be a photographic artifact. So, the best explanation? A motion blur. To catch something as faint as an interstellar object from the surface of Mars, Perseverance's imaging team had to stack hundreds of short exposures over several minutes. During that time, 3I Atlas moved noticeably against the background stars. It's a classic example of how even the most historic images need careful interpretation. And here's a slightly less scientific but equally frustrating detail. Many NASA websites and feeds, ironically, went completely silent right when we needed real-time updates the most. Affected by a government shutdown, shutting down key public access during an interstellar flyby feels awfully convenient, especially when researchers around the world are eagerly pressing to follow what might be the most unusual object ever seen in our solar system. So, what are these incredible pictures actually telling us? From Earth, the comet looked, frankly, like a fuzzy cotton ball. But from Mars, with those incredibly hard-won images, we can measure its coma, that hazy envelope of gas and dust, at a whopping 18,000 kilometers across. That's roughly 50% larger than Earth-based models had predicted. The color, interestingly, is slightly redder than Borisov, hinting at a carbon-rich crust that's been baked by cosmic rays for millions, perhaps even billions of years in interstellar space. But here's one of the most striking things. There is no obvious tail. Scientists fully expected to see significant sublimation of carbon monoxide once the comet passed within 2 AU, astronomical units, of the Sun. Yet spectra from TGO's NOMAD instrument show only a very weak 4.3 micron CO line. This presents us with a couple of fascinating possibilities. Either the nucleus is much smaller than 1 kilometer and has already effectively shut down its activity, or, and this is a wild one, it's coated with an ultra-dark organic gunk that's insulating the ices beneath. Either way, 3I Atlas is proving to be a very different beast from Borisov's much more gas-rich display back in 2019. Now let's talk about the real scientific payoff of this dual-planet observation: parallax. By combining the vantage points from both Earth and Mars, astronomers managed to reduce the uncertainty in the comet's inbound orbit from literally hundreds of astronomical units down to a mere 11. That's an absolutely staggering improvement. This sharpened calculation allows us to pinpoint its original home with unprecedented accuracy. Preliminary results are already pointing toward a G-type star in the Carina-Centaurus Association that, get this, ejected the comet some 30 to 50 million years ago. Think about that for a second. We're now tracing a dirty snowball, a tiny chunk of rock and ice, back to a specific stellar neighborhood some 300 light-years away. It's mind-boggling. And that same trick, that powerful parallax, will let us predict exactly where 3I Atlas will roam once it finally leaves the Sun's sphere of influence, roughly another 20,000 years from now. This whole observation campaign has really sparked some incredible scientific debate and speculation. Avi Loeb, a Harvard professor, has famously argued that given what we expect about the available population and heavy element abundance in interstellar space, we should, by now, have seen far more interstellar objects of more modest sizes before stumbling into one as seemingly massive as 3I Atlas. And that, he suggests, marks 3I Atlas as a significant outlier. Loeb even entertains a speculative alternative, that the object could be of technological origin, a probe from beyond the stars, a piece of alien technology. He cites the unexpectedly large mass, the alignment of its trajectory, and some purported detection of nickel without iron as provocative hints. Now, NASA scientists, quite rightly, urge caution here. The prevailing view remains that it is most likely a natural object. And from the images, we do see that this object is active with a coma, which is a strong indication that it is, in fact, a comet. But let's shift gears for a moment, because some scientists aren't just asking what 3I Atlas is, but what its purpose might be. Astrophysicist Suzanne Pauls has this idea, simple yet striking. 3I Atlas may actually be a planet-making seed. How can a wandering rock from another star system spark the birth of an entire planet? Let's take a quick mental tour. Imagine a young solar system, where a new star sits at the center of a great dusty ring. Here, tiny grains of rock swirl like smoke, gradually clumping together into pebbles. With time, these snowball into boulders and then into planetesimals, the raw ingredients of planets. Given enough time, these grow massive enough to gather even more material. It sounds straightforward, right? But as we'll see, there's a serious problem with this picture. These dusty disks only last a few million years before the gas is blown away. That window seems just too short to explain how massive planets like Jupiter and Saturn were able to form. Now imagine a different scenario. Into this disk falls an interstellar object, a body already big enough to serve as a ready-made core. Instead of starting from dust grains, the disk suddenly has a solid seed that can immediately start pulling in surrounding gas and material. In this way, an alien traveler could literally speed up the birth of a new planet. Simulations actually support this idea.
pals found that massive stars are better at capturing interstellar objects than smaller ones. And sure enough, gas giants are more common around bigger stars. The match between theory and observation is striking. If this is true, then interstellar objects like Oumuamua, Borisov, and now 3I Atlas aren't just drifters, they may be the very sparks that ignite planetary systems. This whole observation campaign proves beyond a shadow of a doubt that assets we have orbiting or parked on Mars can absolutely pivot to celestial mechanics on demand. No new multi-billion-dollar probe had to be launched, no massive mission approved. We just told the spacecraft already there to look up, and they delivered. Expect to see this exact same technique employed the next time an interstellar object tears through the inner solar system. Except by then, we'll also have ESA's JUICE, Jupiter Icy Moons Explorer, and NASA's Europa Clipper loitering in the outer system, ready to join the chase. Every extra baseline, every additional point of view multiplies the scientific return exponentially. Mars just became a permanent, indispensable node in that ad hoc network of deep space observatories. So, what's on the horizon for 3I Atlas? Between now and its perihelion, its closest approach to the Sun in late November, Earth-based telescopes will be continuously monitoring the comet for any sudden outbursts. Meanwhile, those Mars orbiters will continue their weekly check-ins, snapping more images and gathering more data. After the comet recedes back into the depths of space, ESA plans a special data release, including raw FITS files, so that amateur astronomers and citizen scientists can try their own processing. How cool is that?
And the dynamicists? They're already feeding that incredibly refined trajectory data into N-body simulations, hunting for future close stellar approaches. If 3I Atlas passes within a few hundred AU of another star in, say, 1,000,000 years, we might one day image it again, this time from that star's own backyard. The Harvard professor, Avi Loeb, despite his earlier speculations, has also stated that the prevailing view remains that it is most likely a natural object. If you want to stay looped in the next time a spacecraft swivels on a dime to catch a glimpse of the universe's weirdest visitors, then seriously, hit that subscribe button. I'll keep crunching the numbers and translating the cosmic chaos so you can see the universe in real time. Drop your questions about comet tails, parallax, or even Martian overtime pay. Yes, spacecraft overtime is a thing, believe it or not, down in the comments, and I'll answer as many as I possibly can. While you're at it, check out this video right here on how Mars Express keeps limping along after 2 decades. It's a masterclass in interplanetary duct tape. History books, when they're written, will undoubtedly remember 3I Atlas as the comet we caught from 2 planets at once. But more importantly, it's irrefutable proof that our robotic explorers, these incredible machines we send out into the void, are far more versatile, far more capable than we ever even planned for. A rover hunting for ancient microbes, orbiters sniffing for methane, they all paused, looked up into the black, and delivered a stunning family portrait of a traveler that left its star before Earth even had trees. If that doesn't make you excited for the next weird, wonderful thing the sky throws at us, then honestly, nothing will.